Hey guys, so I want to talk to you about liquids and generally how they react and some of the principles are behind them. This is chapter 19 in your book, and I do encourage you to go back to your chapter, read through it. Even though I do give you some notes, it is pretty much a summary of what's in the chapter, but if you want the additional information, which I encourage you to do, go back to your chapter and take a look at that. All right, so take a look at oops, going too far. Look, let's go back one. All right, chapter 19 of liquids. I hope you guys can see that. It's in red. Earth is the only planet that we know of that has water on it. So with that being the case, liquid is unique in all of its principles that we see. Now with liquid, it's a little bit different than if we think about pressure. If we were to take a wooden block and we were just going to set it right on top of a desk, if you think back to earlier in the semester when we studied that, all it does is it puts pressure directly onto the desk, and the desk pushes back. So we end up with that simple Newton's law where equal and opposite reactions. It's exactly the same thing we see here. Now, if we have water, it's a little different. We have to take water, make sure it's in a container, of course, and it has the same amount of pressure that pushes down on the desk. Now, the problem with that is water doesn't only push down on the desk, it's also pushing against the container that it's in. So we see that becomes a little bit of a challenge, a little bit different. Water pushes in all directions at the same time, or liquids in general, inside their container. So it's not just down, it's any direction. All right, buoyancy. What is buoyancy? Buoyancy is the apparent loss of weight of an object once it's submerged into water. Now, if you've ever been swimming, and I assume you have been, and you get in the water and you float, first thing we teach people to do to swim is float, front float, back float, so forth. What that is just buoyancy. Teaching people to control their buoyancy in their water. That's how we do that. Now, buoyancy force is a little different. This is the upward pressure against gravity in the opposite direction, causing displacement. Now, let's talk about displacement for a second. Displacement is when the water, or the object put into water, flows over. So if you've had, say, a glass of water, you drop your little ice cube in there, it displaces that water and it flows up to the side, or maybe even over the side of the water, over the side of the cup. So that's displacement. Now, this leads us to Archimedes' principle. Now, Archimedes' principle says an immersed object is buoyed, buoyant, up by the force of equal in the weight of the fluid it displaces. Now, that force does not depend on the weight of the object. It only depends on the displacement of the fluid. This principle also applies to gas and liquids. Now, what am I talking about here when I talk about this? I'll give you an example. So, for example, if I have some water, let me grab my pen, go back, hold on, boom. Grab my pen, I'll do this in red the same. So let's say we have a beaker of water, and we take a block of steel, okay, and we put that steel into that water. Now, what happens is it goes in, and it floats in there, and it weighs less once it falls in. So we would weigh it. It would weigh, say, 3 newtons. Once it goes into the water, it's in there, it might weigh 1 newton at this point, once the displacement is. So this is Archimedes' principle, saying that a solid object, once it's submerged, will become less in weight and lose weight. So this is Archimedes, is what he was saying. Let's go back and look. Oh, clear my annotations. And back. All right. So an immersed object is buoyed up to the force equal to the weight of the fluid it displaces. So it's going to be equal. Once it goes in, 3 grams in, it comes out 3 newtons. Move forward. Okay, so flotation. The principle of flotation, a floating object displaces the weight of the object of the fluid equal to its own weight. In this is why we see these monstrous aircraft, huge, tons and tons of aircraft be able to float. Now, this is a flotation principle that we're talking about, so the principle of flotation. It also shows the floating object with the displacement of the same amount of water equal to its own weight. Let's take a look at what that may look like with an example. Okay, so for example, if we have this water, okay, and we put that same block of steel that we talked about before right on top, what do you assume it's going to do? Well, it would obviously just sink, go to the bottom. However, if we take that same block of steel on some water and we form it into like a cup or the bottom of a boat, put the keel in there, okay, now what happens is, because of its ability to displace that water, pushing outward, keeping it off, it's able to float. That's why these monstrous ships of steel, even though they're steel, are in a shape where they can displace the water and not sink. Whereas if we look at our friend over here, the steel block, he is not at all able to displace the water. So because he isn't able to displace enough water, I should say, he does displace water, but not enough to stay floating. So that makes it sink. That same piece of steel shaped into a curved bowl stays in place and is able to float and displace enough water. The idea is it has to be large enough at that mass to be able to do that and be able to float. Now, as you get ready to build your boats here, I want you to be thinking about these two principles and how they play into it. We're going to do a couple of exercises, and we'll take a look at how to make that happen. All right, take your notes on this stuff. I encourage you to go back, look at your chapters, chapter 19, and tell me about, include that information from your book into your notes along with what we've talked about here. All right, see you guys later.